God bless you, geometry students. This is a practice for your geometry test coming up either Friday or Thursday, actually tomorrow of this week. So I hope you get an opportunity to look at this. Some of you will need it, I'm sure, more than others. First thing I'm going to look at with you is the foundational scripture for our study of midpoints, mid-segments, perpendicular bisectors, dealing with central issues here. So as we study bisectors, it would be wise to consider a scripture which addresses central issues like of the heart. This one scripture would be Proverbs 4:23, and this says, "Keep your heart with all diligence." Should be heart here. Heart being the center of our lives. For out of it spring the issues of life. The first central issue we're going to be dealing with will be coming up later on. But for now, from 4:8, we look at isosceles triangles, and that's what we got before us here in number 30 from page EP9. As you look at this, you'll see two tick marks here, meaning that this is an isosceles triangle. As soon as you see that, a good idea is to mark the base angles as equal. In this one, they're asking us to find x and y, these two angles here. So these two angles are the same. You know the three angles add up to 180. So the thing to do is to say, okay, I've got one angle as 132 degrees. So let me take that 132 from 180. Work it carefully. Borrow 1 from the 8, leave 7. 10 take away 2 would give me 8. 7 take away 3 is 4. So we've got 48 to be shared equally between these two angles, and they're the same. So we have 48 divided by 2. That would give us 24 degrees for each angle. So x would be the same as y. That would be 24 degrees. This next one at number 31, we've got three arcs here, and that tells us something. It tells us that this is an equiangular triangle. All three angles are the same. And here we want to find y and x. So here we look at it and we say, how can we set it up? Oh, since it's equiangular, it must also be equilateral. So the three sides are the same. If the three sides are the same, then we can set any two of them equal to each other. We could say 2x minus 3 equals y plus 4. That's not going to work with that. Let me come back over here. We could say 2x minus 3 equals y plus 4. Not sure why I'm having that blah blah right, but that would help us because we got x and y in the mix. We want to get just either x by itself or y by itself. So let's try something else. We can have 2x minus 3 equal 11. 2x minus 3 equals 11. Okay, and then we add 3 to both sides. When we do that, we get 2x equals 3 plus 11, that would be 14. And divide both sides by 2, so we get x equals 7. So that would be our x. How about the y? We could say y plus 4, which is this side length, is also equal to 11. So here we could say y plus 4 equals 11. And we subtract 4 from both sides, and that would give us y equals 11 take away 4, that would be 7. So these would be our answers here. X equals 7, y equals 7 happen to be the same for that one. Okay, so the next item we have here will be a little bit more involved. And that will be number 38, where we are doing a transformation from an object at x comma y to an image which is at x minus 3, y plus 7. You see, how do you do that? Well, what this means is that every x value here will be going backwards by 3, and every y value from the object will be going up by 7. So let's say if we take the point P, it will be going back 3, that 1, 2, 3, and then up 7, 1, 2, 3, 4, 5, 6, 7. So the point P for the image will be about here. I'm going to make it P prime, say. How about point S? We go back 3 from here, so we go back 1, 2, 3, and then up 7, 1, 2, 3, 4, 5, 6, 7. Around about here is where point S would be. I'm going to make that S image. Then we get to point R. It goes back 3, 1, 2, 3, and up 7, 1, 2, 3, 4, 5, 6, 7. Around about here. That's R for our image. And finally, point Q is going to move from 4 comma negative 3 to 1, 2, 3, and then up 1, 2, 3, 4, 5, 6, 7. So it's going to be approximately here. Graph is rough, but I trust you'll get the idea. We're going to join these vertices now, like this. Should actually give these dashed lines. This would be our image right here. So this is a transformation based on this template right here. What else is there? Well, let's take a look. The mid segment. And the mid segment is shown right here. Whenever you hear mid segment, it means that this point is a midpoint. That means this is the same as this. And the other endpoint is a midpoint of this segment, so this will be the same as this. And the theorem says the mid segment of a triangle is always equal to 1/2 of the third side. These two sides are the sides where the endpoints go through these two sides, and the mid segment itself is 1/2 of the third side. So if the third side is 24, then the mid segment itself, x, must be 1/2 of 24. I think I said 34 there. 24, 1/2 of 24 should be 12. Okay? How about this one? Here they give you the mid segment is 10.5. If the mid segment is 10.5, the third side will have to be twice 10.5. So x would have to be 2 times 10.5. When you work that out, you get 2 times 5 is 10. And 2 times 10 is 20 plus 1 is 21. This would be 21.0. That would be x. Still working with mid-segment. This one is a little bit more involved. They give us the mid-segment is 16. These marks just mean that this point here is the midpoint of this segment. This point is the midpoint of this segment. So the third side is going to be twice the mid-segment. So the 2x minus 4 will be twice 16, and 2 times 16 is 32. So that's the way you work this one out. So we add 4 to both sides. We get 2x is equal to 32 plus 4, which would be 36. Divide both sides by 2, and we get x is equal to 36 divided by 2, which would be 18. Here's one which is a little bit different, but just really emphasize another feature of the mid-segment. This is the mid-segment here. It says if OE is a mid-segment of the triangle, this triangle HPS, find the following. I'm asking you to find HO. The mid-segment would have an endpoint here, which is a midpoint of side HP. So this would have to be equal to this, and that means then that HO and OP would have to be the same. OP is 7, so HO would have to be 7. How about SE? Over here, SE would have to be the same as EPY because this is a midpoint. So SE would have to be the same as EP, which is 8. So SE is 8. HP. What will be the distance from H to P? Well, it's going to be 7 plus 7. That will be 14. And finally, the distance from S to P, similarly, will be 8 plus 8. That would be 16. So that's so much for the mid segment. And let's go ahead and take a look at our last topic here. This was the perpendicular bisector. It says find the length of AB. Here we have a perpendicular bisector. It's perpendicular to AC and it bisects AC. So this would be a midpoint right here. The theorem says any point on the perpendicular bisector is equidistant from the endpoint. That means point B would be equidistant from the endpoints of AC. What that means is that AB is the same as BC. And that means 2x minus 3 would be equal to x plus 7. And you work that out by adding 3 to both sides. You get 2x equals x plus 10. Subtract x from both sides. And we get, actually this should be plus here, my mistake. So we subtract 3 from both sides, and this should be 4. Subtract x from both sides, and we get x is equal to 4. And to find AB is going to be equal to 2 times whatever x is, and x is 4, plus 3, this would be 8, plus 3, that would be 11. Here, over here we also have a bisector. Bisector is this should be D. BD is a bisector and it's perpendicular. And this one I'll pick up on another video, I think, because my time is just about done. But I'll be